नहीं अभी आपको फिर से देखो फोन में अभी मैं बालू के देखूं मैं बालू के देखूं.
Okay, see, once again, I'll explain here. The compound microscope, there are two lenses. One is objective, the other is eyepiece. Here, what is happening? So here, what will happen? This is the object. The object is placed at the object of AB, which is height h. We are taking two rays. One ray which is parallel to principal axis passes through the focal point. Second ray which passes through optic center goes undeviated. These two rays join and form an image, final image, which is equal to h dash, which is a dash and b dash. Now any object when it is towards when the object which is towards the lens is said to be towards the object is objective, towards the eye is known as eye lens. Now the image which is of the image of objective lens is acting like an object for the eye lens. Now we are taking two rays again, a ray parallel to principal axis will pass through the focal point, and second one which is in this way will go in there. So it will after refraction it diverges. So these two rays are taken back, and the final image is formed, that is a dash b dash, which is formed at a distance of capital D. Now the angle subtended by image object and image is beta, that is h dash. So if you take magnification of the objective, that is h dash by h, or it is equal to b by f, that is L by f, because we are taking the images from somewhere here. What is L? L is the length of the barrel. These two lenses are mounted in a barrel whose length is L. Now M0 is equal to MO is equal to h dash by h, which is also equal to L by FO, and tan beta is equal to what? H by f, which is also equal to h by L. Now, FO is what? Focal length. FO is the focal length of the objective, and FE is the focal length of the eye lens, and U is the objective. Okay, U is the object distance. Now here what is happening? ME is what? These two formulas came from simple microscope when the image is formed at near point and when the image is formed at infinity. Now what we are doing? We are using this formula and we are using these two formulas for calculating the total magnification. The total magnification is given by M is equal to MO into ME. Just multiply it. But this is the final formula. Okay, we'll do a numerical on this, so you will understand it better. Just copy this, okay? In telescope, we have refracting telescope. Refracting telescope, same thing. We have two lenses here. Here objective is big and eye lens is very small. Why? Because the reason is to capture more light. That is the reason. Okay. So this is objective and this is eye lens. Objective and eye lens. So there are two rays. One from here, one is going from here. A ray which is parallel will go in this way. Second one is what? You have taken two rays. These two rays meet in this way. So these two rays meet in this way. So now here now, so here what is that? This is beta. This is beta, this is H. And this is what? A dash and B dash. See, in this case, the object is somewhere far at infinity. Infinity means maybe 1 kilometer or 2 kilometers. Image is formed. Here we have to stretch these two rays backward, then the image is formed at infinity like this. This forms somewhere at infinity. Okay. So now, what is this? Is FO. This distance from here to here is FO. This distance from here to here is FE. Okay. And this is beta and AB. H is the height. Okay. And O is the O is the objective and E is the eye lens. Okay. Here O is the objective and E is the eye lens. Once again from the beginning, there are two lenses here. Objective and eye lens. Objective, the lens which is towards object is objective. The lens which is close to the eye is known as eye lens. Now the object is somewhere at infinity. We are taking the rays incident on the lens, and after refraction it passes through, it converges to a point and the image is formed. This is the image. The image of the objective is acting like object for the eye lens. The image of objective is acting like object for the eye lens. And again we are taking the rays, they diverge and these two rays are taken backward and the image is formed somewhere at infinity. And h is the height of the object. So here what will happen now? So here we have angle here, that is alpha. We have taken alpha and beta. Alpha is the angle subtended by the object. This angle and this angle will be equal. And now this is beta. Beta is the angle subtended by the image. FO is the focal length of the objective and FE is the focal length of the eye lens. FE is the focal length of the eye lens. Now M is equal to what? M is the magnification. M is the magnification, which is equal to what? Beta by alpha. M is beta by alpha, which is equal to what? What is beta here? Beta is equal to H by Fe. Okay, if you take this angle, this is what? This is the focal length and this is the height. So beta is H by Fe divided by what? Alpha. Alpha is H by Fo. Okay, H by Fo, which is equal to what? Which is equal to Fo by Fe. Okay, Fo by Fe. There's a formula. So the length of the telescope is what? Length of the telescope is L is equal to Fo plus Fe. Length of the telescope is Fo plus Fe. And the magnification is what? Suppose here if Fe is 1 centimeter and Fo is 100. Example, if Fe is equal to 1 centimeter and Fo is 100 centimeter, then magnification formula is what? 100 upon 1, which is equal to 100. Means the magnification is done 100 times. The magnification is done 100 times. Okay. And one more thing, if the two stars are separated, example, if there is a pair of stars, if the two stars are they are separated by angle of how much? 1 degree. There are two stars, binary star, what we say, or there are two stars. Example they have given are separated by, actual separation is this much, are separated by one minute. 1 minute. Then if you see through, after magnification, it won't be 1 minute. After magnification, it will be 100 minutes. Okay. When you see magnification, it is how much? 100 minutes. 100 minutes means equal to 1 degree, 67 minutes. This much will be the magnification. Is that clear? In the separation also, it will show this much. Clear? So this was about the refracting telescope. Okay. We have compound microscope. In compound microscope, suppose if length of the barrel equal to how much? 20 centimeter, and FO focal length is 1 centimeter, and we already know least distance of distinct vision is 25 centimeter, and if focal length of the eye lens is 2 centimeter. Okay, 2 centimeter. Then what is the magnification? He's asking what is the magnification. What is the formula for magnification? M is equal to L by Fo into D by Fe. So M equal to what? L by Fo. So what happens here? L is 20 by 1 into D is 25 and Fe is how much? 2. So 2 ones, 2 tens. So magnification M is equal to how much? 250. Means if the size of the object is 1 centimeter, then the magnification of the image will be 250 times more than the object. So there are powerful microscopes, it can magnify 1,000 times, 10,000 times, maybe 1 lakh times also, more than that also. Those microscopes are said to be SEM and TEM, scanning electron microscope and transmission electron microscope, SEM and TEM. These are very powerful microscopes. But here, instead of light, we will be using electrons, beam of electrons. Okay, that is not there for you, but this is a part of modern physics, dual nature of matter and radiation. They actually, with the Davison and Gerber experiment, they found out these powerful microscopes. Okay. Now, one more question we will do on telescope. Okay, so we will try one more question on telescope. In telescope already we did, I think. If the magnification is of the object is 100 and eye length is focal length of the object is 100, focal length of the eye length is 1 centimeter. Just solve it and divide it, you will get the answer. Okay. Now here, so I'm going with the next concept, that is about the Cassegrain telescope, reflecting telescope, which was made by Cassegrain. That I will explain now. For Cassegrain, there is no derivation. Okay. Even for this also, there is only one. So you may ask me, sir, how did we get that actually? Actually, it is tan beta is angle. You can write it, copy there. Beta is angle subtended by image. Angle subtended by image is beta, and alpha is angle subtended by object. Okay, angle subtended by object. So what will happen now? Tan beta equal to what? H by Fe, implies beta is equal to H by Fe, and tan alpha equal to what? H by Fo, which is equal to alpha is equal to H by Fo. Okay, so divide one over the other, then we will get that value. Okay, so that is how it is written. Now going to the last one, please copy this quickly, then we'll go to the last one, that is Cassegrain telescope, reflecting telescope. So that will be the last one, last topic of this lesson. Yeah, we are done with this. Now after that, I'll write all the formulas. Done, Ahmad? Is it done?
Yes, sir.
Okay. Then going with the last one, that is now reflecting telescope. Reflecting telescope. That is said to be Cassegrain. Reflecting telescope. That is Cassegrain telescope. Okay. Now in this one, now Now a ray which is parallel to principal axis. A ray which is parallel to principal axis after, so not like that. Actually, there are, one second, let me just finish off the diagram. So the rays are coming from far, maybe from the space. Okay, they are coming from the space. The rays are coming from a far distance. Okay, so now there are rays incident on the mirror. After incidenting, they reflect. Okay, so they reflect.